sky is a painter, a brush in its hand, sweeping green ribbons across the land. Red whispers follow a secret glow, a waltz of light in the dark below. Auroras waltz, they twirl and spin, a cosmic dance where dreams begin. Green and red, they light the floor. I could watch forever, I want no hold their breath, the moon takes a bow, the ground wears a gown of color somehow. I reach for the sky, it slips through my the night hums softly, the world stands still. The air is electric, the cold gives a thrill. Auroras waltz, they twirl and spin, a cosmic dance where dreams begin. Green and red, they light the floor. I could watch forever, I want no more.
Well, hello everybody. Welcome to Sky Tour live stream. See, I didn't have to let the whole song play through. I wanted to just say thank you for hanging with me. I had the initial time wrong, my mistake, but I fixed it. I got it straightened out. I edited it in time. I believe most people made it here properly. It is I, Mark Antonio, and I am here with another wonderful night. And tonight, if you look up there, you'll see that we have two telescopes. One is a wide field system, and one is a narrow field system. Now, it's not fully dark out there yet. Okay, this screen here, this is the narrow field system, and if I show you, let me just do the processing here. This is what it looks like right now. So you see, it's still a little light. Okay, the other system is this one. This is the wide field system, and the wide field is actually also up and running, of course, as you can see. But we also have some really nice skies there as well. Same telescope. That actually that's Polaris. That's the North Star right there, down there. Okay, and we are pointing at Polaris right now with this telescope. So the wide field catches it. The narrow field, on the other hand, doesn't. It's down more, but that's okay because we won't be pointing at the pole star, Polaris, when it's actually supposed to align the telescope. The telescope's supposed to have an alignment that's like right bing in the middle there. And what we do is we don't point there. We point off the pole because the actual pole of the Earth, the North Pole of the Earth, the actual physical pole is in a different spot than Polaris is, because Polaris is not at the exact North Pole. All right. Because of precession, the Earth does this, right? It wobbles on its axis. So every 26,000 years, the Earth North Pole star changes. So in a few, just over 10 to 12,000, 14,000 years, Vega will be our North Star. All right. So Vega will always be at the North Pole. And so we will see more summertime constellations. We'll have the Milky Way going around the whole northern pole all year round. And that'll be cool because we'll be able to see the Milky Way all year round. But you only have to wait about 14,000 years or so for that to happen. And a faint star that we barely can see called Thuban in Draco was the previous North Star as well. So this, again, wide field. Now the size of this field that you're looking at is 1.5 degrees wide by 1 degree tall. All right, so that's basically 3 full moons by 2 full moons tall. 3 full moons across, 2 full moons tall. Right, and that's a good sized field. Now we also have our system here. You can see, let me do it this way. Okay, you can see we have Venus and Jupiter in the sky right there. We looked at Venus the other day, and as it gets darker and I can get our telescope to see things better, I might take a chance to go check out Venus. Let's take the narrow field and maybe take a visit over to Venus and check it out, because right now we're looking at Polaris with this star, so with this telescope. So let's go. Again, this is the narrow field system, and we're going to head over to the west. Sorry, let's go this way. Notice that we have the Scorpion beginning to rise above the horizon. Scorpius, the Scorpion there, followed by Sagittarius, the Archer down here. That's pretty cool. And let me bring up the music just a tad. All right, so that's pretty cool. Now you can actually see that we have the summertime sky coming. Now the Milky Way is right here, and if I get rid of the atmosphere, you'll be able to see it better. Okay, here comes the Milky Way. All right, and so right now it's on the horizon and rising. So let's put up our lines. So it's still obviously fairly low. As the night moves on, it'll get better. Then as we move over here, toward the south, we'll see a cluster that's just out of our reach right now, and that's the Omega Centauri cluster, the largest globular cluster in the sky. Massive, over 1 million stars in that thing. And then we have Venus and Jupiter here in the west. Now, Venus is only 20 degrees above the horizon. Jupiter is less, so I'm not sure if we'll be able to see Venus very well. It's actually on the other side of the sun from us, so it's farther away, so that's why it's not as bright as it normally is. And I will just see if we can actually go there. All right, so let's try. I connected it, and we should now be able to do this. Okay, you might be able to hear the telescope moving. It's faint, but it's there. All right, and let's see here. If we actually find it in the first shot here. Maybe not, but we do have stars, so we can check our field and correct that. Yeah, okay, we'll have Venus in the middle of this view here in just about 3 seconds. 1, 2, and 3. And there it is. And this is a 1 second photo, so as you can see, it's very, very bright. And it's at 200 gain. Again, the gain is one of the... first of all, probably help if I show you it to you. Okay, sorry about that. So the exposure is how long we're exposing the sensor over here. And the gain is the sensitivity of that sensor. We're going to drop that down to 0 for this. And as you can see, that's much better. I'm going to drop this down. This is the exposure. We're going to make the exposure smaller. And you're going to see just how big Venus actually is. And you'll notice it's not very big in our view here. But we are going to be able to show it. And it's moving around a lot because, of course, it's near the horizon and we have some wind out there. All right, so let's look at this now. Do this. All right, that's actually... It looks like a waxing gibbous moon is what it looks like, which is kind of interesting. And I'm going to... Is it a 0.05? I'm gonna drop our exposure to let's say 1,000th. Okay, that's 1, and let's go to a shorter exposure. Let's go to 4,000th. All right, and you can see it's getting smaller because we're getting less light. It's not bloating, and then we'll go to 8,000th. All right, and you'll see it gets a little bit smaller still. And now that's the farthest we can go there, and then we go to 16,000th. All right, and let's get rid of this too. I should have done that before. That helps us, and now I can increase our exposure incrementally until we start to see it. Here it comes, and this is the best way to do this. Let me just do this. This is fun. Okay, and now let's bring this into view. All right, so now let's zoom in. If we zoom in on this now, again, it's near the horizon, so as you can see, it's kind of fuzzy and dancing around because it's windy still, but the shape of it's actually like a waxing gibbous moon from a distance. Right, so there's the telescope right there up here. All right, and it's pointing right at Venus. We actually were able to find it very well. That's good. And now let's see if we can do a little better on this. There we go. Okay, we almost had it. I think that was better. This right here. You can see the shape. Venus, when it's on our side of the sun, it becomes a somewhat of a crescent. And when it does that, it really is just a beautiful, giant image, and it looks like a true crescent moon from a very, very distant direction. See how it's dancing? Now, if I try to, do a planetary stack right now, all right, you can see as we move more, it's trying to align the frames. All right, but as we collect more, okay, right now we have 18. It'll get rid of more of the noise as we go. Then you'll be able to see it better. You can see that it's not round. It's actually, you can see this beautiful terminator on Venus right there, and this is the cloud side. And of course, we have plenty of clouds on Venus. It's a very, very cloudy planet, unfortunately. But this stack actually looks pretty good, considering. And considering the winds, now we're actually trying to negate the wind, and it seems to be working. So we're gonna call this Venus. Up here, up there at the top there, right here, we label it. And this is how it will appear on skytourlive.org. When you go there and you want to go see it, you can download it directly. Okay, so we got 100 here. We're gonna save this exactly the same. We're gonna save it as a ping, a PNG, and a TIFF. TIFFs are as noise-free as possible. And let's see if we can affect the brightness and color here. Okay, that's a little better. So we'll save it as a TIFF and a PNG again. And you'll see the actual shape of Venus. That's pretty cool. Let's do one more. I'll reset the stack and start again. Again, this shows stacking very well. The first few shots have a lot of digital noise, but as you stack, take an image, stack, take an image, stack, and make an image sandwich, it removes this noise and averages it out, so it literally goes away. And it actually only allows the data to come through, and it gets rid of the noise stuff that ruins the image. So you can see it's coming back, the shape is coming back. I have to say hello to some folks that are here as well. We got a good crowd already today, which is nice. I want to say hi to everybody, but I want to say hi in particular. Let me get myself up here. Yeah, we got Michael Hedrick, who's here with us. Nice to see you, Mike. And, of course, Kathy Mesick, Cornucopia. Good to see you, Courtney. And we have Sally Forth. Hi, Sally. Missed you too, actually. And Ronald, ERRT Radio. Nice to see you. Genghis is here. Genghis was over in Bill Skywatcher's channel, where we're just looking at what he was streaming. And then, let's see. C&D Boy, Bob, how's it going? And Nicholas Guerrero, who was also over there as well on Bill's page, was out there. And we have, oh gosh, we have Thorngood Studios. That's Sharon in Pearland, Texas. She's actually works on our social media, and she's also helping us get noticed a lot more by bigger organizations if we can manage that. If you haven't seen my wife Files appearance yet on the basement, it's basement number 10, and we're almost at 1 million views. So 1 million people have looked at this. Maybe it was 3 guys doing it, 300,000 times and 350,000 times a piece, for all I know. Curtis Horn's with us. Hey, Curtis, how you doing? Good to see you. And Kevin is here from Vancouver. I like hearing where you guys are from, too. I like to know where everybody's from. And we're almost done here. And then we got, let's see. Oh, wow. David Schmidt. David, where you been, buddy? David's our one of our longest distance viewers. He's from Thailand, watching us from over there. And our Australian folks that join us are also pretty long distance as well. And we have Purple Stricker. How you doing? From Hickory, North Carolina. Hey, and the Goblin's with us too. Nice to see you guys. DPFX, how you doing, brother? And then we have NPR TV. Yo, what's happening? And this is Venus right here. It looks pretty good comparatively, compared to what it could be. It's on the horizon, only 20 degrees, So that's pretty cool. Lazy Duke, what's happening? Jason Lusk, how you doing? He says there's a video about pole shift and Eskimos in the Arctic Circle saying the way the sun has moved drastically and changed the weather there. What do you know about it? Oh, well, as far as pole shift goes, that's not as real as they'd have you think. And I'll explain why in just a sec. Let's come out of this and let's go and zoom out to our fit the height here. You can see how small it is. All right, now let's go check something else out while we're here. Jupiter's kind of low, but we'll give it a try. Let's see if Jupiter can slide in the view here. Probably could. There it is. So Jupiter has slid into view here. I have to make sure that we capture it properly. You can see some of the moons. It actually has to be, we have to do this to it, drop it down, and then increase the exposure from a gain of 0, so we're not even adding any exposure to that sensor. All right, and I haven't focused fully yet, so I don't know that it's probably going to work, but I can do this. Let's see if I do this and then zoom in on it. Yeah, we got to give this a little bit of a focus. Okay. Not exactly what I was hoping, but we'll get there. That actually looks like it may work. I'm going to take this down now to these normal levels. Get rid of the overprocessing. Oh. And now let's see. Yeah, it's really low to the horizon, guys. It's not going to come in. We, as Jupiter's setting soon after sunset, we need to, well, relatively soon after. I can see a band anyway, so that's pretty good. What I need to do is focus on some stars first before trying this. All right, so I'm going to back out here. Let's just actually fit the height. There we go. And then let's do this. Let's go to our program here, because we're now about 15 degrees above the horizon. It's going to not show us much of anything. However, I'm going to try this. I'm going to come over here and I'm going to go to the beehive cluster. And the beehive is where we will focus. So telescope will show us the beehive. I'm going to go, there it is, and we're going to focus on this. We're going to do a exposure of 1 second, because I think now we can handle that. It's dark enough, and sure enough we can. And so it's there. You'll notice the stars dance around a little bit. That's the wind. The focus isn't too bad, but I'm gonna bring us in a little closer and see if we can get a little bit better. All right. If not, I'm gonna do the focus run. Okay, that's a little out. All right. And we'll do it this way. This will be a big change. There we go. Those are out. Okay, good. So now, what I'm going to do is do a focus run on this and get my equation solved for maximum focus. And then we'll be able to continue to do some good stuff. Bet if I do this, it won't go all the way back, which is what I want. Okay. So there's the setup stuff that you normally don't see, and it's stuff that I don't mind showing you. I like having to be part of the whole process here. Okay. Let's do this. And now we're gonna go and do one more shot like this. All right, now it's out of focus. So I'm gonna come in here and do our focus run. We have 7 stars captured so far, and we're now gonna go in the opposite direction to focus down and get our beautiful parabolic curve. And at the bottom of that curve, we're going to see the focal point. It won't be exactly where the telescope stops at, but we're going to interpolate and get the bottom one. So while it's doing that, let's go over to our wide field system and grab something else. Let's go and first of all, let's see the field of view here. All right, the field of view is such that Jupiter and Venus just barely will be in the same field. That's how big a field we have here. And let's actually do this. Let's go to the Beehive cluster with this telescope and show you what that looks like. All right, now you'll see the telescope here in the back. Not yet, you won't. Yeah, you will. All right, it's going there now. Right there. There it is. Uh-oh. Not going the right place. I guess we're off. Oh no. That's weird. Let me just confirm where it thinks it is. Yeah, no, it's not there. It's in the wrong place. So we gotta coordinate this and get it to look right. Okay, so we got our. Let's go back over here. We got our focus, and the focus is setting up now. There we go. That's good. Okay, so focus is good here. So now let's come out of there. And now we've got a beautiful focused image, and now we can take this and go to try to look at a 15-degree horizon Jupiter. Yeah, let's see. Well, it's there. All right, now let's see what we can do here. Now that we know it's focused. All right, first things first, we're going to get the brightness down, get us back to a proper exposure. And at 15 degrees above the horizon, you can't expect to see anything miraculous. This is more of an experiment, just to see what we can see. Because we know it's focused. Doesn't look like much. But let's do a planetary stack and see if that'll show us any more detail. And it sure will. Look at that. So we can see a couple of bands. If it was higher in the sky, it'd be much easier to view. It'd be, so much more we could see. But unfortunately, we can't at this point. All right. Well, that's what you get when it's lower the horizon, unfortunately. That's what you get. Okay. Well, that's I guess what we'll have to deal with for now. Now, as far as getting the other scope connected, let's do that. Okay, all right, so here is the other scope, and it's now on the Beehive. There goes a satellite. It looks like a dash because this is a 1 second exposure, so over 1 second it's going that far in the view. That's why it looks that way. And the pink you're seeing is the remnant of the sunset that's still plaguing us right now. All right, we just have to let all that final red imagery go away. All right, but there's the beehive. That's the whole beehive. And with the other telescope, okay, what we see is just a small section, a small few stars here in the middle. All right, and that's pretty cool. Now let me. This is so much fun. I got big data screens in front of me. I got one observatory, the second observatory, and then the broadcast. And it's like a lot of fun. And let me now just take this guy here, and let's look for something else. As you can see, it's not fully dark yet, and that's the orange, the red that we're seeing here. This is Leo up here. Might as well show you this while we're here. And if we go to the Leo triplet, you'll see that the entire Leo triplet will fit in here. So we're gonna go to this guy right here. All right. You can see the telescope there, moving to it up there. And you'll see the crosshairs come in here in just a second. There they are. Okay, and I see one here and one here. I think this is the Leo triplet. Let's bring that up into the view. There they are. Okay, so I'll bring that up. I stay over into the view. Okay, and this will be nice because I can show you the difference between these views. Right now we're only at a gain of 50, and we're going to go to 200 right now. Okay, and then we will. That's how bright the sky still is. Notice, but we're going to cut that down now. So there is the first one, here's the second one, and here is the third one, known as the Hamburger Galaxy. And let's bring it a little higher into the view here. And then what we'll do is move it over a little more. Center it up. I'm centering up the whole triplet as opposed to just one galaxy. Okay. Now, in our other telescope, we're going to do the same thing. We're going to bring that. Okay, this is the Leo triplet. What I'll do now is I'm going to do this. Hopefully it's dark enough to actually get a set of stars to work on, and it is. So now what I'll do is I'll grab a star to guide on, and we'll start guiding. So now we're guiding, and that star is a little bright. Okay. But we're gonna try doing a lower exposure. I want to do a little higher exposure. Yeah, we should have gone to left it at that. Okay. And maybe what I can do is actually select a different star. Well, that one's pretty good actually. Let's do it again, see which one it picks. Okay, well we get a different one, but it works. Okay, that's a better one. You get the nice peak there. Okay, we'll let that run, and what I'm going to do now is I'm going to start this on a 45-second exposure. Again, what we are now is we are in the wide field system. All right, so let's go. That's running, it's starting, and you can see the exposure down here at the right kicking off. There it goes, down there at the lower right. And we'll get out of this and let that go into a live stack. Meanwhile, let's head on over to the other telescope and let's go up and grab the Leo triplet here. But what you'll find is that we see something very different, and that's, we're gonna focus on the Hamburger Galaxy. We're gonna go there and you'll see the difference. So there's the telescope, you see it moving up there now. Telescope's going to be pointing pretty much at the same, exactly at the same thing in the sky, basically. You'll see both of them are pointing at the same thing. And this is sort of an illusion that you're looking at here, a perspective illusion. It doesn't look like they're pointing at the same thing, but believe it or not, they actually are. Okay. And I will show you that more properly in just a moment. Okay, so let's go here now, and first of all, make sure that we are pointing at the right thing. I'm at a gain of 0 right now. I'm going to go to 200. All right, and I'm going to go to 1 second as opposed to a quarter of a second. Get more data in here. And let's see, it looks like take a longer exposure here. Let's say 5 seconds to confirm where I am. We are looking at a deeper sky location, so we have to be but there it is right there. That we want to bring that down in. That's going to be pretty different compared to the other one that we're looking at. So let's look at that. First things first. All right, we're going to go back to 1 second here for a moment. We're going to bring this guy here down to here. So let's do that. Okay. Here we go. Bring it down. Bring it down. And then bring it down. And that's just about it. Hey, Buntis Flint. Nice to see you. Roy Batty's with us. All right. Now, let's do this. Let's go and grab a guide star for this scene. Get rid of that. And give us a little more contrast so you can see what I'm looking at. And pick a guide star. And it's going to check and pick that one, just like I thought. Off we go. And now we're going to do a typical, we're going to do another, we're going to do a 55-second shot of this. All right, and this is the galaxy known as the Hamburger Galaxy. It's the upper galaxy in the triplet, which I'll show you right now once more time. It is this one. Okay, but there's the size of the field for us right now. Okay, that's the size of the field. All right, and so we're going to have this thing filling our field. If we look at our other scope, however, well, that's what we got now. Check that out. This is the entire Leo triplet. Nice, huh? And that shows us the entire view of this particular portion of the sky. All right, and let me get the curves done. Let's get the color correction done. We can color correct a little bit, and then we're going to move this up the average curve of the red, green, and blue, and you can see the detail. All right, now we have, this is the Hamburger Galaxy. That's what we're looking at. Okay, and if we come back to here, all right, let's take a look at that in our live stack. We should have an image coming in here in just a moment. And so back here, we're looking at this guy right here in the other telescope. Right, and that's going to be kind of cool. So this is the Hamburger Galaxy right there. And this is the entire Leo triplet right here. Okay, these galaxies are pretty much almost the same distance. So there's a lot going on here. And so they may or may not be interacting with each other. I think maybe that these two here, these two galaxies are interacting potentially because they're almost the same distance from each other. All right. And in terms of the detail, we just did 55 seconds on this other guy, and I'll show you that. Okay, this is that one. Now, it doesn't look like much yet because we haven't actually processed it at all. I'm going to drag this up the curve, the average curve of the red, green, and blue. Right, and let's just check this. Right, okay, good. And then now pull this. This is the mid-range. We're going to take this mid-range and drop it down a little to kind of subdue some of the noise and allow you to see what's going on. All right, so now let's take a look at the chat and see who's asked anything. Michael Hedrick says, when you said there was a remnant of sunset when you were setting things up, what was the equivalent of another? What was the equivalent? Another question mark. Okay. Can you describe the Bortle scale as level 8? Oh, it's a level 8. Just, I don't know what that means. Like what? Okay. First of all, the Bortle scale, created by John Bortle, goes from basically 0 to 9. If you're in a Bortle 9 location, you're in the center of a big city. And if you're in a Bortle 1 or 2, you're in a relatively dark sky, very dark sky. We are in a Bortle 2.5 to 3 where we are. So our telescopes actually can see quite a lot without having to try hard. For instance, look at this. This is, and I will get rid of this for now. Let's take that down out of the way so you can actually see the whole thing. This is our current view of the Leo triplet. Look at that. So in one view, we have 3 beautiful galaxies. This one you can actually see the detail in the spiral arms. This one you can see the dark lane in the spiral arms. This one you can see its dark lane, of course, very well, with additional stars that are moved out here, flipped out, kicked out, I should say, by interactions most likely with these 2 galaxies. So, and there's ways to figure that out because we can gauge which way gas and dust and stars are moving. And so that would tell us what's happening. Okay, let's go back to, remember taking this picture in the narrow field scope, and this is what that looks like right now. So we're building this up right now. And let's see if we can actually increase our contrast. There we go. Look at that. Now you can see more detail in here. All right. That when you try to look at that same detail in here, okay, if we zoomed in, let's show you the difference in the way the telescopes operate. Okay. Okay, here you're already zoomed in. We're zoomed in at 86% on the sensor, and look at it. It has all kinds of noise in it. We've got color noise, and if we were to try to do a color correction, it may or may not affect some of the color. Here it may have, but you can see the blue stars here that we're in a spate of star formation out there. Now the thing about this telescope is it's about 25 times faster photographically than this one, right? So this one has to expose longer to get, but it gets better quality by far. You can start to see real detail in this ejected dust coming out of this side of the galaxy, right? And if I pull this in a little bit, you might see more. Okay, we only have 5 frames stacked here, as you can see right here. And we're stacking more. in the other telescope right now, we are up to 12 frames that are stacked, because we started it just a little earlier at 45 seconds. Oh, thank you. Shot through the heart. And what we can do with that, though, is we can unstack that and take that one away. And so it goes away. So the next one that comes through will be crisp and clear. And the other one here, the same thing. We can unstack this one as well and get rid of that satellite that went through. Isn't that cool? We're literally taking one of the images off the stack. So it's as if it never happened. Now if I don't catch it, then it'll stay, because we only unstacked the one previous. Very cool. Yeah, and so this guy then is showing more detail, and the camera's far better resolution. All right, and so that doesn't mean it's a superior camera. The camera that we're using on the wide field system here, this camera is actually effectively tuned to this particular telescope to deliver the best results. All right, and so by delivering the best results, it means that we will not have to worry about the telescope, having a delivery of poor pictures at all, which is kind of good. Actually, it's very good. Hang on, I gotta grab something. Almost there. Okay, sorry about that. So yeah, this wide field view is nice, but the native view is this. And that looks nice, but we also have to consider that we don't get the supreme detail like we get in this shot. Okay, so over here you can see this incredible detail here. You'll start to see in here there's much more detail showing up in here than we've seen in the other shot. Let's center it up. Now it's not even fully dark yet, by the way, just so you know. Okay, you saw that sunset shot when we brought this planetarium up before, right? So if we're here, we zoom out, right, you'll notice that the sunset is just about gone, but look at, we still have a little bit here. All right, and we want to get rid of that. So we're not quite there, but I wanted to show you this anyway. Hee. Hope you like it. Okay, so there's a few things to look at tonight that are just exceptional. All right, so this is where we are, and the full field of the Leo triplet is this guy right here that you're seeing. That's what we're seeing here in the other telescope in the wide field system. Okay, so over here we have the Leo triplet, and then here is the field of view of this telescope right here, which is really neat. All right, let's do this guy. All right, so coming over here, let's check it out. You'll see some details in here showing up, which are nice. I could reduce that noise a little bit. All right, and do this. Now, again, the red colors you see in here are remnants of that sunset and the earlier exposures we took. Now we're up to 9. Which corresponds now 10s, which corresponds to 9 minutes 10 seconds. Excellent. Okay, so this is now one that I want to annotate for you. Okay, and it's that galaxy. It is NGC 3628. galaxy, and we're going to set that to be the target name. Then over here in this side, we're just going to call this the Leo triplet because it's all of them. Okay. Make sure you have your resolution set to 1080 so you can actually see the writing in here. Okay, we're at 18 images. I'm going to save right now. Save exactly the scene. Right, so as we speak, all of these images are being uploaded to the cloud and down to our server at skytourlive.org. And you can find every one of these images probably right about now in the server. The delivery is extremely fast. Well, let's go into the chat here and see what people are saying. Mundus talking about Colorado. Autopilot, hey, how are you? Nice to see you. Will the new Vera Rubin pictures be used to replace all of the pictures in Google Sky? It depends. It depends a lot on who has dibs on the Vera Rubin. Okay, I did apply to be the Vera Rubin outreach astronomer, but they wanted someone at last that wasn't me, I guess. So I didn't get the job, but that's okay. I would have enjoyed that. And I still would have been able to do this because I would have been working in Tucson the whole time. So I would have been down there. But it's kind of cool. And I can't wait to see what the Vera Rubin produces. Let's go see our other shot. Yeah, okay. So that looks pretty. And you'll notice that it says narrow field right here. So we are in the narrow field. That's how you know we're there, because you'll see that coming up. Right? And let's save with annotations anyway. Yep. Okay. And then we can get rid of this and save it. If we hit save and then save, to a PNG file, it doesn't save the annotations even if I left them up. Okay, so not a problem. Really pretty though. That's a gorgeous galaxy. You'll notice that the red is getting further and further away from us. It's disappearing a little. And there we go. Look at that. That's really something. Yeah. Really something. That's pretty. So our guiding and our systems are doing great here. I'm really impressed. And I also want to say that we have a second building here on site. And we are planning on putting another telescope in there. And I'm just working on it right now, trying to get that arranged. If I could tell you more, I would. Curtis, you asked me earlier how Contact in the Desert was. And I started to write it, and I never finished it. I said Contact in the Desert was great, and there's what I wrote. But we did take the donation of another telescope while there. Very surprising, very amazing, and wonderful. And I'm hoping it wasn't a dream. But we'll keep you posted on that. There's more to it as we move forward. All right. Here's our other view right now. This is now at 23 stacked images, and it's the Leo triplet, and I shall now save that. This galaxy is looking really pretty. I guess I should move to that galaxy now too, because that's actually brighter, and this galaxy is somewhat faint. So I'll do that. Let me save exactly as seen, and also 24. Nice. Yeah, sorry. Good. Okay, so now over here, this is the Hamburger Galaxy, as I said. We can bring our mid-level curve in more to kind of extract more data. And we can do this to bring that data line right to the very top of the peak. It's called a push. We want to avoid that if we can. We don't want to go past that peak. We want to stay before it. But this is cool. Thorngood Studios asks, if stars are formed in galaxies, why are there so many rogue stars? Aha! That's a very good question, because it's the result of a common misconception of what we're looking at. Every one of those stars you see in the sky here in this image are up here in our foreground galaxy. You're seeing through all of them to galaxies millions of light years away. All right, so those are all in the foreground. Even the smallest star you can see there is a star in our foreground. I hope that makes sense. All right, so that's a really good question, though. And then Ginga says, the one on the right looks as if it was thrown out of the galactic plane. Talking about this guy here. Well, these kind of are all at different angles to each other, actually. But they do look interesting, no doubt. If that's what you mean there, Gigas. Munda says, if I'm ever a fighter pilot, I want my call sign to be Rogue Planet. That's cool. That's really cool. JSCO, hey man, thanks. And Michael Hendrick has a question. Let's just go back and watch here. What are each of the planets' respective North Stars? Oh, that's a really good question too. All of them have different North Stars than ours, obviously. If we weren't at 23.5 degrees in our axial tilt, then we would have the same relative North Star as some of the other planets in our solar system. But they're all different for the most part. And Uranus is the most different of all because its rotational axis is 89 degrees. So it's almost laying effectively what we'll call flat in our solar system. And that's probably from some massive collision early in its formation. But the North Stars are all different. Leonard Thuman says, out of the three, which one is the closest and which is the furthest? Again, spectacular question. Let's go show you directly. If we look here, right, and look in our triplet, this is the Hamburger Galaxy here, and the Hamburger Galaxy is at a distance of 45 million light years. So you're seeing it as it was 45 million years ago. This one here is known as Messier 66, and this one, its distance is given all right as 35 million light years. So this is 45, this is 35. This one, on the other hand, its distance actually isn't given here. We could figure it out though from its redshift, which is given here. There's the redshift number. And rather than go through all that, let's suffice it to say that it's a similar distance to Messier 66, and this is Messier 65, I believe. Oops, sorry. Let me zoom in on that. Yeah, that's Messier 66, and this is Messier 65. There you go. All right, so pretty cool. Our next galaxy we're going to go look at is this one, and that's going to be this one right here. The thing is, this one shines in this view as well. So let's save this one last time. All right, with 20 frames, and then we will hop out of our narrow view here, our magnified view. Go back to our low light view. That was our deep sky view, I meant to say. All right, so there's our deep sky view. Now we'll will fit the height so we can get the entire field in here. Now let's go to another one where you can see this really, really shine. Okay, so let's go to this one. And we're on the way. And you're going to see right away, you're going to see, well, you're going to hear, there it is. You're going to hear that this is complaining because it can't guide anymore. And that is correct. It can't guide anymore. All right, so what we're going to do is bring this one in to our view a little bit more. This again is our narrow field system. All right. All right, we're going to bring that into the middle. And we're gonna continue to just let this one crank away. Why not? You know, let it go. The more we take, the better it looks. It's looking at the same thing that we're looking at here. All right, so let's come over here and just center that up a little better. Right about there. Okay. And now I have it on 2 seconds per frame. Let's get another guide frame. All right, now let's get a star. Yeah, that's the one I wanted. There we go. This guiding should be nice and solid. So we'll come out of here now and we'll do a, let's say, 35-second shot of this. And we'll do that, and then we'll go into deep sky mode. We'll pop out of this and hop into deep sky. This is neat. Okay, let's see. TP Seekers says, any idea when the North Star will change? Actually, that's again, you guys are just full of great questions. It changes very slowly. It's changing all the time in terms of how the North Star is drifting, because as the Earth's rotation is moving on its teetering top path, it's slowly changing all the time. So every year you can see updates to the positions of the North Star in our relative sky, Polaris that is, and so you'll see that the North Star is changing over time, and so it's going to be, you know, over 13 or 14,000 years that the Earth's teetering top is going to move to get Vega, a very bright star in the northern sky, to actually be the North Star. But it will. It was before, and it will be again. Check it out. This is pretty. Let's also drop that down. There we go. Go to full size. Yo, check it out. Let's zoom in. Wow. All right. First things first. Let me color correct any problems we have here. Good. And now let's put this where it belongs. This is the dark line. This should actually be to the left of the curve. You can see how much more data becomes available when we do that. We'll move this up. And you can see that we're getting the detail in those spiral arms now. Drop this down. And again, the galaxy we're looking at is this one right here. All right. And that is in there, right there. So moving forward, you'll see this start to get a lot more detail in here. That's what's really cool. Toner Low says, I've heard it mentioned that Vega was made in the same planetary nebula as our sun. Is there any truth to that? I don't know the answer to that question. I would venture to say probably not. I'll tell you why in a minute. I said a minute because I had to take a drink of water. Okay, first of all, I have a lecture that I go through. I talk about this in part. We do have a solar twin, the sun is not alone. It wasn't formed alone. It was formed with other stars. And it's formed from the same nebula of material, pool of materials basically in space, that our sun was formed in. Or sorry, that other stars are formed in our nebula. So they all form together. And then because of gravitational pulls and so forth, they migrate away from each other as they orbit the very, very tumultuous and populated galaxy. So in so doing, what we'll find is that the sun, with its very specific chemistry and composition, will migrate away from other stars that were formed with it. And those stars will have the very same exact composition as our sun. You can't have stars formed elsewhere that are different compositions if they're formed in the same nebula, because that nebula has pretty much the same compositions throughout. So you can actually do that, mathematically figure out, and spectroscopically figure out if there's another star out there with the same composition as our sun. And guess what? We found one. It's exactly the same amount, and so of materials. And so that means we found the solar twin. We found a star that was just like our sun. That doesn't mean it has any planets, but it might, So we should look, which I do believe we're doing. Okay, so again, we're looking at this guy right here. Okay, and that's right there, right? This is the narrow field view. This is the wide field view of this exact scene. So that's the difference between these telescopes, and I'm just so happy that they're in the same building together. Oh yeah, very much. Very, very nice. All right. Okay, so now this is looking nice. And how many did we stack here so far? 9. All right, so we stacked 9 images in here. Let's try and pull in some more detail. Mundus asks, is it even possible to have a star without any planets orbiting it? Absolutely true, yes. How many planets do you think are around all of the belt stars in Orion, which constitute from left to right Alnitak, Alnilam, and Mintaka? We can tell you none. How do we know that? Because we have something going on in within those 3 stars called powerful stellar winds and very, very high radiation. So the stellar winds from those O-type stars will push away any material around it that could be used to make planets. And that's exactly what has been happening there. So that's unfortunate, sadly. Now, what I also wanted to do while we're waiting for this to come in is I wanted to show you something. And that I will show you in just a sec. Let's wait for this though. This is coming in. Look, it's getting even more detailed. You can start to see more detail in here now. In this area, you can start to see it. Wow. See, there's dark nebulae, there's dark clouds in there. You can see detail within there that you just can't see when you zoom in to this in the same way. This is a what we call a higher focal length shot. Actually, and within this one, you can see that it looks sort of like it's white. This is a full color shot though, because you can see that this dust truly is brown right here. Okay, as is this. But you can't see any real detail in here. But if you come over to this other guy, now you can see the detail and the separation and the data and the spiral arm dust in here. That's important. That's really important. Okay, so the other thing I wanted to show you is when we did the installation. I wanted to show you how that went. So I'm going to do that here. All right, let me do this here. I'm gonna take us down while we're waiting for this. I'm gonna take us down to this new. Oh, look, it's all of you. Maybe this guy. How about this? Will you do that? There it is. Okay, so now we have it here. All right. That's kind of weird. Why is that there? Oh, I know why. Just a moment. There we go. Okay. So during the installation, we stuck it on a big tripod with a very heavy mount. This is a dew shield that we had to make on the fly because this particular dew shield that we had before was longer than this, and it interfered with the other telescope a little bit. So we went out to a store, bought some very felt lined fabric with rubber on the outside, and we actually built it inside the building quick and dirty to get this thing up and running. And you'll notice that it's on a tripod that's on top of concrete blocks. It should be on another concrete block, but I figured I'm not going to mess with this. I'm going to see that it works. Right? So let's see. Oh, well, that's not what I wanted. That was something totally different. Wow. All right. I was trying to show you something, and this song starts to play. Okay. All right. So let's see if we go this way. Oh, no, that's a model I'm making, a Navy model. So what I got to do is I have to come in here and do it like this. Let's see if this will work. Okay, so here is our guy that helps us, who lives out there in Benson. He's helping us put this together. This is not easy. What we're doing right there is we're trying to lift this tube up and hold these weights down. Because of the way the leverage is, the tube is not balanced yet. And that's what we're doing. We're figuring out the balance. So that's why his hands are there. You notice his hands are not like gripping tightly. We're almost at a balance point. But I'm actually trying to get the balance. We're moving these weights back and forth to get the balance. And right now, you notice there's only 2 weights on here. There needs to be 3. So right now, it's really, really hard to hold this up, down like that, because there's a lot of weight on this trying to drop that tube. So Glenn here is holding the tube up, and I'm about to get the 3rd weight and slide it on the end here, which is kind of cool. And then we did that, and by doing that, we ended up, let's see if I can get this out of the way. There we go. So let's do this now. All right, so once we managed to do that, and by the way, getting this to get up on this cradle here, we had to take this entire tube assembly. There's the original dew shield. And take this entire assembly and get it up on top of this cradle. Not easy with 2 people. And Marianne was there to help us as well. And that wasn't, it was cramped and very difficult to do. And she did help us. All right. So let's see. The next one, which I think is a good one to see, is after we got it loaded. All right. And I will show you that. And that's this guy that I'll make visible here in a sec. All right. And that is this guy. All right. So here I am sitting in the chair. Roof is off. This is the original Benson scope, and this is the new scope here. And I'm actually looking at my phone to connect and do some parameters here. This computer is here. We also have one here, but I could use this computer to connect to this computer. So I was controlling it from a quote-unquote distance, and that was like 6 feet. The telescope didn't know it wasn't being controlled from 6 feet away. Right now, it's being controlled from 2,600 miles away. And this is all very helpful, right? So that's that guy. And, you know, so then we had this set up. Now, I was told, drink your water. So I had to make sure I got a picture of me drinking water, because I'll tell you, out in the desert, water is what you need. The temperature in here was around 105 this day. But it was also low humidity. So you didn't know when you were sweating, and your sweat would just evaporate off your body. So all this mess was cleaned up, and everything is now nice and orderly in there, which is really cool. Very helpful, very helpful. So that is pretty much it. So I hope you enjoyed that little preview of what it took to get these images for you. I enjoy making sure that people know what it is we do. Okay, so here is this beautiful image. It is now, we're at 24. We're going to go to 25 and stop there. And then move on to another pair, which are beautiful. And Jason Lusk asks, how was that tech surviving in those temps? Well, keep in mind that when you have like a circuit or something, it could run at like 175 degrees and be perfectly fine, right? So same thing here. We can have it running very, very hot, and it doesn't get hurt. Now, does that mean it won't hurt? Oh, no, not at all. It can. We just have to be very careful. All right. Now, the other thing, let's head over here. Actually, no, let's go back to this guy. I want to bring up this image right now. This is our nighttime image. This is not our all-sky. Our all-sky camera's in the building out there, but I have to set it up. I haven't set it up out there. We just ran out of time. You can imagine it was quite a achievement to do what we did. And I wasn't sure we were going to get it all done in time, but we did. I just loved it. Okay, so now, one thing I want to do here is save this. Okay, I talked so much, I went to 27. All right, I'll save it. And so, okay, and then I'm going to save exactly a scene. And if some of you noticed that I didn't rename the file, you're correct. I could do it now, and it's probably a good idea. Alright, so that is M66. I'm going to set the target name. It's going to complain, and I'm going to say yes, it's okay. Yes, it's okay. And save the image, and it'll save this new image in the directory for it. Okay, and then we'll get out of here and save the image directly, and save exactly a scene. Oh yeah, so let's see what people are saying in the chat. 105, how was the tech surviving those temps? I answered. JSCO answered another question. Munda says, sweet setup. We'll wait to see the other one. Oh, man. And then Mr. Django's with us. How you doing, guys? What's up? Yep. Nice. And then, and Munda says, looks like a lot of fun to set up. I'll tell you what it is. It's nerve-wracking, Mundus, and here's why. You're sitting in that building, knowing full well that in just a few days you're going to be 2,600 miles from it. And you have to have duplicate methods for doing everything. Because what if you lose connection to one of the telescopes? How do you get it back? We have a workaround that may work. Sometimes it does. Most times it does. But what if it doesn't? Then we have to figure out what to do. So it's really crazy. And so yeah, it's wonderful. And so far we haven't had a whole lot of serious problems at all with it. But we could, Mr. Django says, glad you're back. Yeah, I'm back. I did 3 lectures in the Skywatch out at Contact in the Desert. The Skywatch I did with Ben Hansen, good friend. And we knocked them dead. They loved it. And so that was nice. Ben and I get along very well. We're good friends. All right, so let's save this for the last time and then move on to the next set of objects. All right, we'll kind of come out of deep sky mode and go back into our low light mode right here. And we are at only 200 gain. I can go up to 600, but the noise increases exponentially when we do that, and that's just not good. All right, so it's a constant trade-off between one and the other. All right, we're going to fit the height now. Okay, so now let's try backing out of this for a minute and checking out something else. It's really a good object to use because it's really beautifully shows. It really shows beautifully what we're trying to do with the absolutely stunning. What am I trying to say? The absolute stunning difference between the two views that I'm about to show you. All right, let's go over. I think I'm way up there. Move it, move it. There we go. I got to move it, move it. We're going here. Remember King Julian from what movie was that? Madagascar, was it? Well, what happened? Yeah, my son got a dog that looks just like King Julian. And he also, if you remember this, it was a show, a Saturday morning cartoon, and it had Zaboomafoo, the lemur. It looks just like a lemur, It's a lemur or a lemur. Yeah, he's got lemur eyes. He's got the lemur kind of coloration. It's really pretty dog. Okay, we're gonna go here to the cluster Measure 13 in Hercules. You watch the telescope move now. There it goes. And of course, we now lose our guiding. I'm going to turn that down because that's probably annoying to you guys having to hear that. All right, telescope is spinning around, doing a flip maneuver. And you'll notice it coming back. Let's go over here. You'll see it come in now. Right there. Let's see, do we get it? After the flip. It's such a narrow field that I don't guarantee anything. So what I'll do is do this. I'll just do a 5-second view. We won't be that far from it. And after 5 seconds, we'll get more stars, and then we can actually do a hunt and a scan. We found it. It's let's see, it looks like it's 0.74 degrees. It'll be right here, right about now. There we go. All right, so there is the great star cluster in Hercules. Okay, and it's going to be moving in. It's a 5-second photo, so let's go back to 1 second. There we go. Okay, there we are. Beautiful. Okay, now let's do this. Let's go here to our guiding system and get our guide stars. Here we are. You got a guide star that's beautiful. Perfect. Look at that beautiful peak without going out. Ah, that's great. All right. And now we're going to start doing a 25-second photo. It's underway. Meanwhile, over in our wide field, we're still taking pictures. Look at this. We're framing with satellites. Let's go do this. Let us now save. First of all, let's see if we can color correct a little better. Oh, yes. Now we'll save it and save it exactly as seen. All right. All right. And now let's go over to the same object that we're looking at here in the other telescope, Measure 13. Okay. And there we go. I've got this now set up. And let's come back here. And I'll just tell it to go to Measure 13 so we don't have to actually... That guy. Okay, and that's the size of the field. All right, so let's go. And the telescope is moving, as you can see up there. So it's spinning its weights up higher, and it's going to be looking up in the sky here. You see how it's flipping around? I'm going to just do one thing. I'm going to take this guy and pop it out and do that. So we can do that. Here we are. And there's Measure 13. All right. Now this is great because it's going to give you a beautiful view that's going to tell you exactly how the two telescopes differ. If I would only go the right way. Here we go. Okay. Okay, let's bring it in. Center it up. So this telescope is really good for large nebulae as well as expansive clusters like the Beehive, which is expansive. All right, so here it is. This is the Measure 13 cluster, in global cluster. All right, and now I'm gonna do one thing too. While I'm here, I'm gonna come down the image control and do a white balance thing here. They have auto set? No, I don't think so. Okay. Just a minuties. Take it down. I'll bring it up. And bring it up slowly. Okay, that's pretty good. That approximates the sky. Okay, now let's go see what it looks like in the other telescope. So there it is in this telescope. Here it is in this one. Now that's a very, very different look. And now what we'll do is we're gonna live stack this too. And we should have the first image right now. Now that is not bad. That's a really pretty shot. Now I'm going to do this as well. I'm going to take this out of the view for now. And let's just get our colors straightened out a little. And now notice that our black level's way past the curve. It should be to the left of the curve. Okay, so we're going to take that and move it over to just off the edge of the curve. Like that. And because it's such a, actually it's a bigger telescope than our other one. So now you see it. Here you go. This is Messier 13. Look at that. That is a pretty cluster, without a doubt. Again, we have this, then we have that, this, and that. So each telescope has its benefits. See what I mean? Really cool. So let's see what's happening here in the chat. Jason says, I bought my daughter songs from Charlie Brown and she was nuts about them. Oh yeah. I used to watch the Peanuts and Charlie Brown just to hear Snoopy. When you go, make that. His voice was hilarious. I just love that. That was the thing that I wanted to hear. Okay. Yeah, Jason, look at all the stars. Now, here's something interesting about this cluster, okay, and other clusters like it. One of the things that we notice about globular clusters is that they are amongst the oldest things in the universe, okay? So this guy here is made of stars that were literally made among the first stars in the universe. Well, what that means for all of you is when the stars in their cores are making elements, and if these stars are among the first made, then they couldn't have had much of a selection of material to be formed with. So, and we find that that's true. So what happens is these stars, being first formed, have the least amount of elements in their outer atmospheres from which they were formed. You look at our sun, you got potassium and calcium and hydrogen, helium, carbon, nitrogen, oxygen. You have all kinds of elements that we see in our periodic table in the atmosphere of the sun. But the atmosphere meaning the outer part of the sun, not the core where the fusion's going on. In the core, there's hydrogen, and it's fusing into helium. And that hydrogen fusing into helium is something interesting. Hold on a second, I'm just going to do this. Hydrogen being made into helium in the core of our sun, that's only 15 to 20% of the size of the sun. All the rest of the sun that you see, the bright thing in the sky, is that bright because of that small 15 to 20% in the middle. And that 15 to 20% in the middle is causing all of the atoms of hydrogen gas and other elements that it was made with to lose their electrons entirely, ionize. And when you have a bunch of free electrons roaming around and a bunch of free protons roaming around, we call that plasma. So the outer part of the sun, which isn't doing any fusion, is not contributing to the heat we feel, all right, is most of the volume of the sun. The smallest part of the volume of the sun, the smallest volume of the sun is the actual energy producing center core. So when the sun was made, it was made with hydrogen gas that coalesced, and the hydrogen was compressed and compressed and compressed, but also compressed along with it were these additional elements. But in order for those elements to fuse, you needed much higher temperatures. And if there was any iron in the sun, which there is, then that cannot fuse. And the reason that can't fuse has to do with the amount of energy you get back with fusion. When you try to make iron fuse into some other element, it actually requires more energy than you get back. So it's a logical stopping point for fusion. It can't go any further. And there's a special name for that we won't go into today. But that particular process, all those elements that we're talking about that are in the sun now, those are what the sun was made with, as I said, and they were made in countless supernovae events and littering of interstellar debris from previous star death that occurred in the universe. And when we look at things like this, the globular clusters, I didn't forget my point, and we notice that they have like hydrogen and maybe helium in them, and maybe a couple other trace elements, we notice that they were made with mostly hydrogen and maybe some helium. And that means they were made back when the universe was first formed. So they're among the oldest objects in the universe based on their composition. Because every time there's a supernova, more elements are made and litter the cosmos from stellar cores where these elements are made, because stars are element factories. So our periodic table is populated by stars. And when they explode, this debris makes its way out into the universe, where a new star is made from it, new planets are made from it. Here's an interesting fact that some of you may or may not know. I'm guessing you probably do. Gold in our universe is made in only one place primarily, and that's with the collisions of neutron stars and the merging of neutron stars. Very special star, but when they merge, this merger is so powerful it can make gold, and that's something that we basically didn't know for a long time, till we figured out that you need these incredible pressures to make them, and this does. That's what happens inside a star like that. So now this particular finding is such that when we look at stars like this, this also means something else, and which goes back to another question one of you mentioned earlier, and that was, look at all these stars and think about how much human life there must be. I'd venture to say there's none, and it's because you don't have such a variety of materials from which to make planets. So where's the carbon going to come from? Where's the oxygen going to come from? Where's the silicon going to come from to make soils and so forth? Where's all that going to come from? The answer is, it's probably not, because these stars don't have it within them to do that. So globular clusters may not have a tremendous variety of materials with which to make planets in there. But I've said this before, and I'm gonna tell you it's gonna be proven someday. Globular clusters are halo objects. They go around the outside of the galaxy, okay, and they orbit in and out of they'll plunge through the spiral arms, then come up through the spiral arms, or they'll be outside the whole galaxy as a whole. Well, the fact is that when they plunge into the galaxy, it's inevitable that their gravitational attraction is going to pull some stars with it. And it's inevitable that if it passes through a dense cluster of stars in the center of our galaxy, that, or in one of the spiral arms of our galaxy, where they're more likely go, that it may leave stars behind. So I have a feeling that the globular clusters are going to have stars in them that don't make sense. And by that I mean they're going to have stars that are more than just hydrogen and helium. And I think I'm going to have to look up whether that study was done, because I suspect very strongly that if they're plunging through the galactic disk, they're probably shedding stars and gaining stars each time they do it. But what a beautiful cluster. And this is Messier 13, the globular cluster in Hercules. I'm going to set this as our target, okay, and save it. So we'll save the annotation, and then we'll save this with however many I took, 16. That's perfect. Very nice. Save exactly as seen. Now there's a few theories about where globular clusters come from, what their origins are, and some of the theories are interesting. I don't know yet. I mean, I give all of the theories a fair shake. One of them, one of them is that the globular clusters are the remnant cores of dwarf galaxies that collided with our Milky Way. Not sure I buy that one, but if you think about it, how would a cluster of stars form like this? And another question is, do they have black holes in the middle? Well, maybe. It's possible that they all do. I'm not sure they do. So, anyway, Ronald, I have to tell you, I was just out in Benson, this past weekend. And I had to work on getting this second telescope installed. So, even though you live in Benson, I didn't even have the time to come see you. So, I apologize for that. And he's probably going, what? What are you talking about? But don't worry. We're going to take care of you. So Michael Hedrick says, globular cluster in Flemish is Kogelvormige Sternhoop. Is that what you said, Mr. Django? Wow. I'm beside myself. And then Mr. Django says, Bolvormik. Bolvormik. Okay. Egash. Mr. Django says, can we see the difference between wide and narrow again, Mark? Yes, of course. This is the narrow field where we're seeing these stars here, this setup. This is the wide field. Now, as you can see, we are basically 1.5 degrees across the screen, okay, by 1 degree tall. All right, and this guy is literally just about, 20 arc minutes across? I calculated it, and I have a reticle in here. I can get that and show you. Let's go look. This will tell me. I'd like to do it without stars in the way. We are, get rid of this. Yeah, 19.84. So it's a square sensor, so it's 20 arc minutes across each way, which is neat. All right, now let's since we're here, let's go and look for one other thing now that we're here. Actually, let's see if we can do it here. That's Corona Borealis. I want to do this. Back out of it. It's Corona Borealis. It keeps flipping around on me. And I want to be... Okay. It's not letting me do it right. So let me just do it this way. That's what I want. It wasn't letting me do it. Okay. So Coma Berenices is another place where there's a cool object, and we're going to look at that next, and that's this one. All right, and it's called the Black Eye Galaxy. Telescope is moving, as you can see. There it goes. All right. And we're flipping around. Boy, if anyone's there going, wow, one of these two telescopes doing this crazy stuff. Okay. And then, while that's doing that, we're going to come over here and go to the same thing here. And we'll just call it Black Eye, because that's where we're going. Here it is. Off we go. And the telescope's gonna do its same flip around. Meanwhile, over in the other telescope, while it's doing its thing, you can watch it keep moving over there. We're gonna make sure that we capture the black eye galaxy. I'll do a 3-second photo here. I believe that it's right. That might be right there. It is right there. Okay. Isn't that it? I gotta check. Let's do a 10-second, 12-second photo. Probably not. Or maybe it is. I'm not sure. Kind of looks star-like. That's the thing. It looks very much like that. But we'll see. Okay, well that doesn't look too good because I didn't guide on it. All right, let's do another 5-second shot here. A lot of stars though. There we go. And let's see if we can grab it. No, it didn't have enough stars, so we got to do a longer exposure, which means that we have to do this and say get a shot. All right. Okay, that'll work. Now let's try again. Yeah, we got some wind. You see, it's the 5-second photos just bouncing around. All right, just a second. Let's just do now another 12-second shot now that we're guiding. Oh, we had one there, but let's make sure we can still. Yeah, we're bouncing around the wind. Mr. Django asks if we're using a satellite connection. The answer is yes, we are. We are using Starlink here. And you can see the antenna right here. It sticks up above the observatory, unfortunately, but it's okay. I don't think it's going to be able to find basically. Oh, try that with smudges. Yeah, we got it. Excellent. Okay. So we're going to move over and you'll see the black eye galaxy in this field here in just a second. There it is. Boom. All right. And let's move it up into the field of view. First things first, go back to this guy. All right. And now let's move this up into the view. We got some wind, so it may be tricky to photograph, but we're going to keep trying. All right. And then that's good enough. All right. Now let's go over here and take this guy, tell it stop, reacquire stars. Let's see here. There's very few stars here, but let's see if we can find any. I don't think it's gonna find any stars. Oh wait, maybe. All right, let's see if that'll work. Jeez, that's kind of tough. All right, let me try one thing. Let's get out of this for a minute. And let's bring it up into the view more. Okay. Let's try that and see if that will net us a better view. Alright, I'm going to do this. I'm going to go up to 2.5 seconds and try and get a star that we can use here. We'll try that. Well, we'll give it a shot. We'll give it a shot. There's literally, as you can see in the field, there is not a whole lot of, we can do because there's not many stars to guide on. Well, it's guiding on that one, so that's okay. So now let's go and do a 25-second shot here. All right, and while that's doing that, and we'll go into the live stack and go into deep sky mode. All right, now let's come over into this guy, and we're gonna go look at that. That is this is what we want, and let's do a couple things here. Let us let us find out what we have for guide stars in this one. First things first, let's move it over. Okay. Okay. Oh, thank you, Starlink. And then we will come over here. Yes, I know, because I moved. And let's get a guide star now by taking a new photograph of the field. That looks like a good star. Very nice star. Very good star. Okay. Now what we'll do is let that guide and then settle down. Now we're going to do a 25-second here, and we'll go into deep sky mode and live stack. This is the Black Eye Galaxy. All right, and meanwhile, while it's cranking it up, let's go look at this one. Obviously, this one requires an assist because we were having trouble finding the guide stars. So I'm going to clear it and see if we can get it to come in. So again, it's a 25-second photo, same as the other one. Yeah, and it's not coming. The wind is pretty high out there, which is kind of whacked. Now we come back to this one, and let's do several adjustments. Okay, and now let's come over here. You'll see this curve refine itself better. There it is. As soon as we get another exposure. This is the wide field view of this particular galaxy. Right, and then I'll move it down. You'll see that it has a real neat dark lane of dust, and that dark lane of dust that's in it is what causes it to be called the black eye. See right in there? See that little dark lane right there? That's the dust. Now let's go back over to our other one and try to refine that. Come back here. I'm going to try this again. Okay, got some stars. Let's see if I... Okay, well, we got stars in here. Selecty, selecty. Okay. Now, let's see if the wind has died down, because it takes some time for the wind to die down. And we get winds. We'll go to Whitefield for now. We get all kinds of wind out there, and sometimes the wind is very, very hard. One of the nights I was there, I got caught in a dust storm. Yeah, dust storms, usually from desert whipped up sand, sent up thousands of feet in the air. And it's really, really hard for that dust to come back to the ground when it's been airborne and sent up so high. So it takes it a while to get back down. And when it does, it can be like a sandblaster hitting your car. It really is crazy. So if you like your paint job on your really nice car out in Arizona, don't like it too much. Sooner or later, a dust storm is going to get you. And you're probably going to have to figure out a way to get that car in a garage really fast. That's okay. Okay, this one is working now. Really pretty. I was looking at the other feed. And let's go see how that's coming. We have about 12 seconds left out of 25. Let's see what we get. I got a better read on this thing here. Let's see if the wind is... Hey, look at that. That's pretty good. We are working better. But look at the difference in size between that and this. That's the wide field system. There is the entire extent of the galaxy right there. And when you come over here, here is the extent. It is literally many times the size of the previous one. So this is why wide field and narrow field systems work well together. Now, if it was still winter or as we approach summer, as you'll see, we're going to be able to see and image things that are just unbelievable, nebulae that are just unfathomably beautiful. All right, and you'll enjoy it very much so. I want to say hi to Jessica, who just joined us, I think. Jessica S., how are you? Okay, and yeah, ring that bell for notifications. And so let's see. Okay, we're rejecting frames here because it can't align, I guarantee, because of the wind, which is no fun. Okay. That wasn't guiding, that was something else. This must have stopped. Nope, still going. Why is that happening? I'm gonna take that off. Just try to take the next frame regardless and not try to align. Let's see what we get. It's going to align automatically with the guider. Okay, that's working. Now, the thing about the noise that we see here is interesting because when you actually double the number of frames you're stacking, okay, images that are slapped on top of each other, when you double those, effectively you cut the noise in half. I mean, that's a pretty good approximation. Oh, see, we did that and I can't unstack it, so we ruined it. My mistake. The wind is killing this one, guys. Sorry. Robert Very, how are you? What's going on? Nice to see you. Star Traveler, how you doing? This is a real black eye for your astrophotography. In fact, it is a real black eye. But in the wide field system, this is what we see. So it's actually a really beautiful image. We've got 16 images here. So there's the black eye galaxy. We can actually pull this down a little more and kind of darken up the background. Again, the wide field view. In the narrow field view, we are way more stringent. And so what's happening is we're getting enough perturbation or disturbance to our imagery from this wind that it's causing it to make it difficult. Now, the other thing is if you look at their systems up here, one of them here, this is the, let me just get there. This one is the one that is shooting up into the sky there, but this one is sitting up there far higher. So it's affected by the wind way more. So the one on the left is the one that we just installed. I should say the one on the left of the bottom view. Let me just show you. Okay, so here we go. Let's go there now. All right. So here is that view there, and now what I'll do is take us to this view. All right, so this view here, which you don't even know what I'm talking about until you see it move. This is the view of the two telescopes. And I got, I have the, I have to turn off, one of these infrared systems we don't need. Night vision IR, we're going to turn off for that particular telescope. So you'll notice a bright light disappeared on top because we are now looking at the view without it. Okay. And then here. Alright, that's actually kind of a pretty pose for the telescopes. I'm going to take a photo. There we go. Alright, so that's where we are right now. Okay, we are, it's constantly dumping these frames down here. So it's having trouble guiding on these, so I'm going to have to change up some stuff here. Maybe I'll come out of here, go back to this and this. All right, and now let's move it. Let's try that. That's not good. I want to bring it a little more up. All right, let's see if we can find a good guide star here. I think we got a good guide star here. Yeah, it didn't find the one I wanted, so I may have to just grab it. Okay. Now that's a good guide star. And it's going to probably stay. So now I'll be able to take the image I want to take. All right. Now we'll do we'll do 25 seconds. Why not? All right. So down on the bottom here, you'll notice that we have a ticker here. This is the progress bar. Okay. And you can see the two telescopes up there just fine. All right, and let's go back into our live stack now and go here. Oh, look at that. Still got wind. Well, I don't get it. But it happens now and then. Oh, look at how far off it went. Yeah, wind really blew the telescope tube, no doubt. Let's do this again. Yeah, you can see the wind blew it. Okay. Let's clear this. Come back here. Yeah, see that the wind put it down here, then back there. Again, narrow field. Small changes make a big difference. In this telescope, they don't. Because it's such a wide field that it takes more movement to become noticeable. So back here, though, we have to worry about that. Yeah, okay. Okay, well, I'm going to abandon this target because it ain't working here. The wind is making it too difficult. We had winds of it said like 25 miles an hour. And normally I wouldn't open, but I felt that it was going to go away after the sunset. And it kind of sort of did, but it's still here. So here's 30 frames for this guy. And I'm going to assign the name. And then we'll save. No, we're not yet. We're going to set the target name. Actually, do it now. Set the target name. And then we will save the image with annotations. And then come out and save it directly here. So now we'll save it. And it's been saved to that directory. Save exactly as seen. Again, wide and narrow field. Now, sorry, that was this I was doing. Sorry. All right. I need to do this. Yeah, look at you can see it's moving quite a lot actually. Okay, let's try one thing here. One other thing that might work better. We're gonna go up here. I'm not sure it'll work better, but we'll try. No, not that. And not this one. Although that's really pretty. We'll try this famous one, the Whirlpool Galaxy, and give that a shot. Alright, 23 million light years away. This galaxy is probably one of the more fun ones. Let's see if we can confirm our position. Okay, take a 3-second shot and do that. Ooh, man, look at that. Boy, the wind is really blowing, guys. So I'm afraid that we will not get the opportunity to do this. Yeah, it's really blowing. Look at that. I can't get a steady shot. Well, that's okay. With a narrow field system, that makes it hard. Let's try a different target then. See if this will work. Maybe something a little bit lower. You know, Okay. We can try. We'll do M82 and go there. So let's do that. I'm just going to run down the M82. You'll notice the telescope's going to go lower, which is important because it might save us. Okay, let's watch and see. Oh boy, now we're still getting it. We're still getting it blowing around. Oh yeah. Okay. I hate to say it, but a wind is going to cause us to have to abort tonight because we're getting blown around here tremendously. So not too exciting. See that? That's the telescope getting blown around. Not good for the scope. Not good for. I mean, it won't. The scope won't be hurt by this kind of wind, but it's enough to shake the tube, and all it has to do is shake a tiny bit. Well, sorry to be having to quit so soon, but I will have to say we're gonna have this image to remember and use. We're gonna save it here, and I think that is cool. So we'll have this one. Hope you guys had a good time tonight, and let's bring this back. I was hoping we would go tonight. This was a bonus stream. We will have our regular Friday night streams. Again, it's going to start later because we want to be able to get into this stuff. So that's what we're going to do. I want to thank Thorngood Studios, one of our affiliates, for joining us tonight, helping us out. And I want to thank all of you for joining us and helping us out. This is a wonderful time. We got to see a few things with the wide field and narrow field. And when summer comes, guys, oh gosh, the sky is going to be so much different. We're going to have so much more to see. So I think it'll be really, really good. And by then, we may have some surprises for you as well that we're working on. So thank you guys, and I hope you have a good, great evening. I'm looking forward to having you all back again. And if you guys are of a mind to, you can support us with our Patreon, okay, if you want. And if you support us with our Patreon up here, a couple things. You can get free images from us every month that are highly processed. So not just the raw ones you get here, but very highly finished processed ones suitable for framing and so forth and blowing up. Or you can get those directly from us as well. You can also, if you join our Patreon, you also get access to, at any level, the music album that we made called Rising, and it showcases music that we wrote and composed and produced for all of you to enjoy. All right, so that said, I am going to take another drink of water, and then I'm going to probably have to go to bed because I'm not too happy about the wind out there destroying our images tonight. So hope you guys have a good night, and we'll see you again very, very soon. Thank you all, and good night.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to sea, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream. Living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every